Hey, hello there. Today I want to talk about question 218, the Skyline problem. So the question is super long. Let me try to give a summarization about the problem. So basically we're taking a picture of the city from very far away, and there are a bunch of buildings on the picture. Each building can be sort of roughly represented by a rectangle. So to encode the rectangle information on this image, we use triplets. That's going to be the left x value, right x value, and the height, the y value for this building. So now our input is going to be a list of triplets, each triplet corresponding to a building. Now these buildings collectively form a skyline, so that's just the outer contour formed by all these buildings. And to encode this outer contour, we can use a list of tuples. Each tuple here is corresponding to a red dot here. That means from this x position and on until you see the next tuple, the height is going to be the given value here. So in this particular example, it will look like 210 for the first tuple. Means that from x position 2 and on until you see the next tuple, the height is going to be 10. So that's the way we use to represent the outer contour in this problem. So the question is basically, given the left hand side, it wants us to output the right hand side. How we go about solve this? So if we so I basically just copied that example from question over to this software so that I can do a little bit more exploration interactively. So just imagine that we have a line that we can swipe through this problem space from left to right. We do this from left to right because the wrong line encoding, the contour encoding is in this format sorted by the x. So just imagine that we are swiping this line through this picture. When we encounter a left-hand side of the building, we might need to deal with this situation because if the building has a height that's higher than the prior skyline, as shown here, we see the first building, which is at the x position 2, have a height of 10, which is higher than the prior. Prior is basically ground here. Because on the left hand side, before this bar, there's nothing. So we have to update the skyline. So we insert a 210 tuple into the output. So then we keep swiping the line. Then we find another building that has a height of 15. It starts at 3, so we put a tuple, new tuple 315 onto the skyline. Now, when we encounter this little building here, it starts at x position 5, has a height of 12. We will remember the height, but we will not update the skyline because 12 is less than the current highest height. So we just remember that, but don't do any kind of update to the output. Just keep swiping the line. When we encounter the right hand side, meaning that the building ends here, and since this building, particular building we're looking at, the red one, is tallest, is the current tallest. Once this building finished, we have to drop the skyline to be the prior second, possibly the prior second highest building, or the current highest building, which is going to be the green building with height 12. So we'll insert 7, 12 onto the skyline. 7 here is the endpoint, the right hand side of the tallest, the previous tallest building, and the 12 is the current tallest building's height. So basically just kind of swiping the line and dealing with those kind of events. So very intuitively we will have two type of event, which is going to be triggered by when we encounter a left-hand side, which is a starting position for a building, and the other type of event is going to be when we swipe the line at the right-hand side of the building, which means the height can potentially drop, the end of that height, the building's height. So we basically we can convert the input triplets into a sequence of events, and now our problem now just becomes process all these events in sequence. Depending on whether it's opening or it's closing, we'll do some kind of logic and to try to populate this output. So as you can see here, based on the prior kind of illustration, at any given time, we want to keep track of the height, the active building's height. So, you know, because that when we have the highest building ends, we want to drop the height to be the second highest, because basically gonna once the building ends, we want to remove that possible height and use the new highest one. And so for that, we have to basically keep this building thing here. That's representing, that's help us to keep track of the current building. That the line has the line is in the middle of that building, basically. So we that's going to be the building we haven't 100% sure that we have already processed. So that's what we want to keep track of when we processing those events. So just gonna do some kind of a little bit animation about how we're gonna process this two different type of event. So the first event we're gonna encounter is x equal to 2, the height of the building is 10, and it's a starting point for building. So we're just gonna remember the building's height, which is 10, and put this 210 tuple onto the skyline. So we originally it's the ground, the height is 0. When we see a high building, tall building, we upgrade our skyline to that position from this particular x position. So that's basically translating to code is that if we are processing a starting event and the height of that building is taller than strictly taller than the prior or current tallest 0 by default, because the ground line, the horizontal line is 0, horizon line, or I don't know how you call it. If it's taller than the prior tallest point, we're gonna append the tuple x and h into the skyline, and also add this height to the building, to the current buildings our line has interacted with. So that's processing this first event here. The second event, before we talk about the second event, let's talk about the special case when we have two buildings starting at the same x position but of different height. Because how the code logic here works is that when we see a height that's higher than the prior tallest, the height, we're gonna put that onto the skyline. So if we have buildings that starting at the same position, we want to process them in a way that's from tallest to smallest, so that this test here can guard us from inserting duplicates value into the skyline. But the reason that we still want to care about the shorter one is that the shorter one can outlast the longer one. So once we finish the longer one, we might need to reduce the skyline. So that's why we have to process both of those two buildings, but we want to do so in an order that's tallest first. So that's this. Or we can do is to check the previous check for the x, the last element on the skyline. If they have the same x value, we try to update the h to be the highest. In that way, we don't care about the order. But the order can be really simply done by sorting. So I prefer just do a sort instead of checking whether we have the same x to determine do we insert or update the tuple on the skyline. So that's about inserting for this first building height here. Then we move the line towards right, encounter the starting point for the red building. So the process is as similar to the prior. We find now it's a starting event, and the height is taller than the current tallest. The current tallest is 10. So we find something that's the height is 15. It's not 7. So 15 is larger than 10. So we want to insert this tuple 315 onto the skyline, and add the 15 onto the building heights. Then moving the line further towards right, we encounter the starting point for a third building. This is a typo. The new building has a height of 12, starting at the X position 5. Because the height is not taller than the current tallest. The current tallest is 15. Then we don't do this append, but we will definitely add this to the building height. So the indentation for this logic is wrong. Anyway, it's just adding that to the building list. Basically, the height of all the current active building heights. So that's how we handle the third event here. Now just moving the line even towards right, we've encountered our right first ending event. So how we handle that? The logic is laid out here. Basically, the ending event means that the building of that height has to end here. So the thing we do is to remove the height, the building's height 15 from the active building's height. So basically get rid of 15 from this list or data structure, so that the result will be 12 and 10. 12 is the height of the green one, and 10 is the height of the blue one. Those two are still there because the line hasn't completely swiped through those yet. But 15 has to go because we triggered the event by the endpoint of the red building. So we have to get rid of 15, and then we do a really quick test to see is the removed building the current tallest. So we can do so by just testing the relationship between 15 and the new tallest one, which is going to be 12. Since that the 15 is larger than 12, that means once we remove the red building, we have to insert a new skyline point into the skyline. So we append X, the position where this happens, and the current tallest building height onto the skyline. So we insert 7 and 12. 12 is the height of the green building. So that's how we handle the ending event. Here is another sidetrack that is to show if we have two buildings or multiple buildings end at the same position, how are we going to do this? What's the order we're going to process them would be better. We want to process them from the shortest to the tallest, because notice that we get rid of 12 and then get rid of 15 and compare 15 with the new tallest. So if we process this removal, if we have multiple buildings like 15 and 20 or 30 all end at the same time, and if we do that in the tallest to shortest, we're going to insert the second shortest onto the skyline, because we get rid of the red one and put the height of the blue one onto there. But what if blue has to be removed too? So if we do this in the tallest to the shortest, we're gonna end up with unnecessary duplicates on the skyline. So we have to process them in the shortest to the tallest way. So that's the order we're gonna process the ending events. So all this, from the tallest to the shortest when we're dealing with the opening, from the shortest to the tallest when we're dealing with the ending, all this can be handled by sorting of all these events. So that's telling us basically when we convert all those triplets, the left and right and height, into two type of events, the X position, the height, and the type, we want to sort them by first X. That's corresponding to the line sweeping event triggering kind of an order. We process from left to right. So we first sort by X, then we sort by the type. We want to process starting first and then processing ending. The reason being that if we're processing ending first, we might insert you know, something like let's say that we have a, let's put it onto the back. If we process ending first, the red building ending here, we're gonna put the height of a blue one onto the skyline. But then we have a purple one that's even higher. Then we're gonna insert another tuple with the same x value but a higher y value. That's gonna be problematic. So for that reason, we want to, for the same x position, we want to always do the start event first before we do the end event. The very last thing is to sort by the type multiplied by the height. If we use negative number for the start and positive number indicating the end event, this will cause us to basically, if we have the same position, if it's all starting position, then we're going to deal with this from the tallest to shortest, because the tallest one multiplied by -1 is going to be negative number. When we sort that in the increasing order, that's corresponding to tallest building first. If it's ending event, the height is going to multiply by a positive number, so that it's going to be from shortest to tallest. So yeah, so that's pretty much this. Super important. When we convert the input into a sequence of events, we do this sorting. Then the main logic is basically here. So now there's only one thing that's remaining. What's going to be the data structure we use for this temporary kind of memory to keep track of the active buildings? Basically means the buildings that the line still it's in the middle of that building. We have some choice. Let's look at what we will require the data structure to do. We need to do remove by a value. So that's unfortunately linear time algorithm, linear time for most of the you know, sequential kind of a container kind of a data structure. And what else do we need from it? We want to get to the current tallest from this container. So we want to do constant check for the current maximum. So that leads us to think about the priority queue. And also we have addition. We want to add things into the collection. So if we use the priority queue, max priority queue, the current tallest one, this query will be in constant time. The add will be log n time, but the remove is going to be linear time. There could be some modification to the priority queue that solve the problem, and that can give us a linear time removal of a given key. But it's doable. So we're basically just going to couple that with some kind of a map to access directly to an element on this priority queue. If we do the removal, we can use that key value pair to access that element on the private queue and do a swap with the tail element on the priority queue. And after that, we're just going to remove the tail. So if we do that, there are going to be some serious modification to the priority queue data structure to enable a log n time removal of the given key value here. But that's doable. So if we use priority queue, just to summarize, if we can have a very efficiently implemented priority queue for this problem, it's going to be constant time for getting the current tallest and log n time for remove and add. I'm not going to do that today. So just going to code this solution up. This is the first solution. I think it's pretty intuitive. Basically, we have two types of events. When we see a building that can potentially need, we potentially needs to update the height of the skyline. When we encounter the end of the building, we need to potentially drop the skyline. And for all the building that hasn't ended yet, we have to keep track of their height. And any given time, what we care is the current tallest one. So that leads us to use a maximum priority queue. Yeah, so that's pretty much the analysis. Let's code. It's gonna be quite few code. So the first thing is to convert the triplets into events for left, right, and height in buildings. We want to insert those in there. Left, height, and -1, that means it's starting. And we're going to do the similar thing for ending events indicated by a +1 in the end. So after that we want to sort the events. The sorting is let me grab the sorting order. We sort by this. Oh no. We sort by X and by the type, and then by type multiplied by height. So that's x0, x2, and x2 multiplied by x1. So that's the order we sort this. So we want to process them in the from left to right. We want to deal with the starting first and then ending. And for the starting, we want to deal with the tallest to shortest. When it's ending, we want to deal with all those buildings in the from the shortest to the tallest. So that's this here. This order is not trivial. So then let's code the main logic part for generating this wrong lines encoding sort of structure for the output. We're gonna have a skyline. Initially it's empty, and we're gonna have a priority queue, which is gonna hold the active building's height. Initially it's empty too. And we're gonna process event by event, given the x position, the height, and the type. So what's the logic gonna be looking like? If it's starting, if it's ending, that's gonna be separate 2 blocks. So if type is equal to -1, meaning that it's a starting position for a building, what we want to do is to test if this height of this new building we see is taller than the current tallest building we have. We're always gonna do this add. Why it's not indented correctly in my notes? Anyway, so if this height is higher than the priority queue dot front, I'm gonna code up a maximum priority queue for this. If it's taller, I append it, and I would also push this onto the priority queue. Else is gonna be the event is gonna be an ending event. If it's an ending event, we will first remove this height. Then we would test it, do we have to drop the skyline? If we do have to drop the skyline, we'll do that here. So it's going to be pq dot remove the height, and then we're going to do the similar test. If it's the removed height is taller than the current highest one, that means the skyline have to drop from the previous height to the new highest. And in the end, we will just return the skyline. Now the thing is just to implement this maximum priority queue. We just have a list for the container, and we will need front, need a push and remove. For the front, we would need to output a default 0 if there are no active building. So if there is no active building, we have to update this skyline to be the ground level, meaning that's going to be 0. And also in the beginning, the skyline level is 0. So if not, so the reason that I'm doing negation is basically I'm going to using the heap queue from Python, and that's only min priority queue. So I have to do the negation to make the high to make this maximum priority queue. So the push is going to just be this heap queue dot heap push. We're going to push this the negative value of the height onto the priority queue. And remove is to remove the value from the container. I'm not going to do the most efficient implementation, so it's not going to be log time. This remove is linear time, and just do a heapify. After remove, I want to have the priority queue to remain the to still remain the heap property, meaning that the front is always going to be the largest one. So that's that. Yeah, let's quickly check if I have problems. Oops, sorry. So that's basically a wrapper on the heap queue to turn that into a maximum queue, maximum priority queue. And here is the conversion from the triplets, the building information into events. We have two types of events, the starting and the ending of a building, and we sort that by the X position, then by the type of the event, then by the height in the correct order. For the starting event, we want that to be highest to shortest. For the closing, we want that to be the shortest to highest. And then is the processing of event by event. If it's a starting event, we check if the building is taller than the current tallest. If it's taller, that means we have to move the skyline up. And after we move the skyline up, we push this. No matter whether we do this push or not, change of the insert of the skyline or not, whether we do that or not, we always insert this new building's height onto the priority queue. If it's an ending event, we remove the height associated with this building that's ending, and then we see do we have to drop the skyline. If we do have to drop the skyline, we append that information onto the onto the result. So that looks okay. So it's accepted, but it's pretty slow. Let me try to move over there and see, and not do illustrate why it's so slow. As you can see here, the inefficient implementation for this data structure that holds the active building, the height of the active building here, I'm using a priority queue, and the remove here is linear time, because you have to traverse the container and find the height and do a remove. After that, you have to do you have to also do a heapify. I think heapify is also, in the worst case, going to be linear. So the remove here is linear, and we have linear number of events. So the total runtime for this is going to be n squared. If we have efficient implementation for this remove, it will be true n log n. It's going to be faster, but not super faster. The reason being that is we still have to pop all the shorter buildings here. Let's just talk about this picture here. Basically, we have a bunch of buildings that's going to be ending at the same X position. So when the line swipe over to the right hand side of all this building, we're gonna pop them out from this active building data structure one at a time. So every one of those little box here would trigger this else branch and do a remove and do a test and do a append. So only the first building being removed would trigger this event, because the second tallest one is taller than all of those. So only that first one would trigger an update in the Skyline. And we are doing a bunch of seemingly unnecessary removal there, because if I'm lazy, or as a human intuitively doing this Skyline drawing ourselves, doing a bunch of building ending at the same time, I don't really care about those little really short buildings that's got buried by this second tallest one. So I don't really want to do this removal one at a time. If just to remove one, I can get to the updated version of updated new Skyline height. So how we deal with it, we still have to get rid of those little buildings in some time, but it seems that in this particular time, it's not the best idea to get rid of all of them in sequence. So that is suggesting us to rethink about the definition of the event, and also that we really want to use pop, the priority queue pop, to have it to be true login time, instead of having to hack the data structure, have a map to somehow be able to directly access this element on the container, do a swapping, and try to avoid doing that. So I'm just gonna show the very last picture here. So the way to do that is we modify the event and modify what's going to be on the active building. For each active building, we will keep track of not just the height, but the ending position as well, so that when we trigger event, like this event here, we get rid of the tallest one. That's the ending event. We do that, and then as long as the new tallest height is higher than those little ones, we postpone getting rid of those. What's going to be the time when we have to get rid of those little ones is when, let's say we have a building far towards right. After that building, purple building is ending. When we're processing this building here, we will look back to see, do we have any kind of finished building that's taller than this one? If it's taller, we want to get rid of them. We can do so by looking at the right-hand side of that building. If that taller building compared to this new shortest one, new tallest one, if that building ends before this, I can pop that at that time. So that's why instead of just putting a height there, we have to explicitly managing this very aggressively, doing a bunch of processing when we really have this kind of worst case scenario. Instead of doing that, we're gonna keep track of two things: the height, and also at which point we don't care about this building's height. So to do that, we have to do this event differently. The event is going to be the x position, the height, and until what x value this height is still valid. So that's going to be the new event, and each building will basically be converted into potentially two events. The starting the event that's keeping track of describing the building, and also the we have to remember to close those. So for every position that we need to do a closing, we just have one thing for that. There are multiple buildings can end at the same place, so we can potentially just using one of this closing event to indicating that. So let's say that those two buildings end at the same place. end at the same 7th position, instead of doing 3 individual events to get rid of the older buildings and decrease the skyline. Here, if we do this event in this way, we will just trigger the event once. So just summarize, if we rethink about what's event and what we keep track of when we have buildings that can potentially affect the skyline to be this tuple, it's basically going to be whenever there is an event triggering, we want to make sure that the current, the tallest building here is still valid. So we're going to do potentially some popping to test the X position and the tallest building's valid property, the second element. If the current tallest building it's no longer valid compared to the event triggering X position, we pop that out. So it's an actual priority keep pop, so it's guaranteed to be log n time. It's not going to be this remove. So that's the first thing we do. We make sure that the active building's tallest height is still valid, and then if this new event is putting a building onto the is the starting point of a new building, we push this onto the building. If 1 and 2 cause the tallest building change, that means we have to update the skyline. So we do this update of skyline in the 3rd step. So that's summarization about if we reframe the definition about the event and what we keep track of the active buildings. This is the main logic. Yeah. And last thing to mention before we jump to the code is going to be the order, so how we sort this event. Of course, the first thing is going to be the X position. We still do left to right. And the second thing is we want to deal with the buildings from tallest to shortest. The reason being that if similar to the reason for in the prior setting, when it's a new building here, we want to deal with tallest to shortest, because if we do shortest to tallest, we sequentially push those onto the active building, and the tallest building is going to change multiple times, and we don't want to do duplicate update to skyline. So we sort by in this order. Yeah, so with that, let's get back to code and do some modification to the code. So that's the old event. Let me actually just get rid of this so that we have fresh, nicer looking code. If you want to look at the not so efficient implementation solution, you can check out the GitHub for the code. So we have 2 kinds of events. We have the starting events, which describe the whole building and how long the height is going to be valid. The closing event is going to be the summarization about all the endpoints, and we do deduplication by using a set. Closing events is a set for left, right, height in events. We put a tuple here at the left hand side, the height, and the right hand side. And closing events, add 0, the right hand side 0, and some dummy number. 0 will be fine. So we can tell whether event is a closing or opening by looking at the height. If the height is some positive number, that means it's an opening event, starting event. If the height is 0, that means we have to trigger some kind of a closing event. So that's that. We're just going to add the closing event to this opening event. The reason we don't add this directly to events is that we can use a set to do some deduplication. So if we have a bunch of buildings ending at the same position, we're gonna only trigger this ending event just once. I have to rush now. So this is the order when we sort the events. We're still going to use this maximum queue, do some modification to it. I don't need the remover anymore. I need a pop. So instead of just putting a height, I will put a tuple, which is going to be the height and the valid information. And pop is going to be just that. So the front has to be changed a little bit as well. So in the case there is the container is empty, we still want to output 0, but now it's a tuple. So what do we put on the right hand side? The valid location. This 0 is valid throughout the number line. So here we put a very, very big number. So I put in the maximum here. Otherwise, I will just outputting this tuple. So that's some modification to the priority queue. We can potentially accepting initial data. So that's that. Do we need that? No, we don't. So my daughter is crying, so I have to get to her. So that's modification to the priority queue. We removed the remove operation, added the pop. So and did some modification to the push and pop because the elements on going to be on this maximum queue is going to be a tuple. The height and the validity until which X position this height is still available. Front here we will output 0 until the end of this number line if it's empty. Otherwise we will just outputting the current tallest building. So let's just code this very quickly. So here is the popping. We have to make sure that this is still valid. So if this event triggering X is far towards right compared to the current tallest building's validity, we want to pop it off. So after this while loop, we make sure that the current active building tallest one is still valid. Then we just test if this is a opening event. We will push this information to the priority queue. So H and X. I'm just going to type without talking now. Yeah, so this is it. Jeez. Pop missing one record position T. I don't need that. Damn. Not working. So this is the code. I have the wrong